We have set up the OpenAI API environment, explored how to work with OpenAI libraries, learn to monitor token usage through OpenAI platforms, and in our last session, we built our first OpenAI powered app, an interactive quiz generator using Gradio and the OpenAI API. Let's explore one of the most powerful features of OpenAI, which are extracting structured data from unstructured human language, and which will bring us to an important concept of function calling. In this lesson, we will see how to use function calling to turn natural language into structured, actionable data. So let's head to Jupyter Notebook and get started. Alright friends, let's start by creating duplicate of the first script which we created in our first lesson of setting up environment, where we made our first API call, and we already have in this script how to load OpenAI, how to create client, and we can also see our first call. So we have already got a copy over here, and the name is function calling. So you can adjust the heading and all is same. Let's begin by reviewing our first OpenAI call. When we sent a prompt to the OpenAI API, we received a response in an unstructured text format. We access this response using response.choices.message.content. Now, consider an example where we provide a job description prompt. It mentions a requirement for a highly skilled data scientist to join a company's headquarters, followed by role responsibility and qualification requirement, like minimum years of experience and specific skills. Now, in real world application, we wouldn't want to manually parse this text. Instead, we would want to extract key details like years of experience, required skill, company location in a structured format, which could be readily used for storage, display, or further processing. And the good news is that we can do this easily using Chat Completion API itself. And let's see how we can implement and extract structured data from natural language input. So let's do that. So let's begin by our first step, creating user prompt, and all we want over here is extracting job information in a JSON format from given job description, and that is what our user prompted. So let's write it. Now we have already specified the string job description, and we can pass this as a variable like in regular Python we do within a curly braces. Now the next step is to write a response like we did over here. So I'll just copy this over here from our first call. Let's comment this out. So we have this response which is obtained from Chat Completion AI, and instead of this content, tell me more about gravity, I'll simply pass my user prompt string over here. Alright, the one thing to note over here is in this format itself, I'm specifying that I want my response in JSON format. So let's just print the response first over here. Let's run it. So we have this, and it specifies that this is JSON and field free and all that stuff, right? Now, additionally, what we can do over here itself in this object, we can specify the response. We can pass one more parameter called response format, where we can specify the type of the object to be returned. So currently this type is definitely not a JSON format, but we want directly a JSON format, and that's what we can tell, that the type of the response should be JSON object, and the rest of the things remain same. So let's run this again. Okay, I have to pass a comma over here. So the type of the response object has changed from string to this. That is how you can see it is so simple to extract structured response from this data. Now the problem over here is every time you will run this, not necessarily in this response, you will see the response itself varies, right? As we can see over here, the fields will vary, and in case we are further processing this data, further displaying this data, or storing this data, we want to standardize this response, and that is where comes the role of function calling, which is a powerful feature in OpenAI, and we will be just looking at it soon. So as we will implement function calling, we will see that function calling is simply a set of rules or a tool that clearly outlines the expected structure of the output, and by passing this tool, okay, as an argument of our API call, we guide the model to produce output that strictly follows the defined schema. Now this approach will offer several advantages, and first one we will be immediately implementing. That is, one is the reliable structure, which ensures consistent key value output, making integration with external systems smooth and predictable. At later point, we will see that we can do multiple function calls. We can trigger multiple functions in a single response for handling more complex tasks. We'll see example of that. And further to that, we can also make external API integration in case needed. Let's say real-time weather or stock price by calling external API based on user input. So let's now implement our first example of function calling and see it in action. Let's start by defining the message variable, which we are taking outside, and then we are further to that we are defining response the way we did earlier. Now here, instead of this response format is equal to JSON object, I'll just remove it, and here I will just pass messages is equal to the messages which we have already defined as variable. All good so far, and we'll get the response in usual manner. Now to define the consistent output, we will make use of function calling, and for that we have to pass an additional argument called tools equal to function definition. Now let's start by defining this set of rules. How should it look like? So we will define a variable called function underscore definition, and here in this we will define a list which starts with dictionary, where we are defining the type of it, and further to that we are defining another key called function, so that we can define multiple functions over here. This is our first function, which is again a dictionary. Now within this function, where we want to extract the job information, we will start by the name of the function. Let's name it extract job info. We can provide the description of function, which tells what the function does. Then we can have another key called parameters. Now this parameters key defines the expected structure of inputs, and again it is a dictionary. So first of all, its type is object. It contains different keys and fields in the object. So we will define the key properties, where in each property we will be defining, which is again a dictionary, and within this we will be defining the each field. So let's say in our case, so we want to define a job title. Let's name it as job title. So we want to extract job title. Type of field is string, and we can again give the description of this field as job title. Similarly, we can extract other property, like let's say location, company information, or the job description says specifically what is the experience required, and then the skills. Now coming to skills, there can be many skills. There cannot be a single skill, right, in a job description. So we can define these skills instead of type string, as we can define it as type array. Then we can extract the items of this array, which individually are of type string. I hope I am not messing with the curly braces. We can give the description of this skills. So let's see what we get now. So if we see the function definition, we have this. The type is function. First of the function is extract job info, the description, what are the parameters, and the parameters, inside parameters we are defining different keys and fields along with the description and the type of those fields. Now comes the next part where we are defining the response. Let's just cut it from here. Let's pass it below function definition. Now in this we are giving the response. Now let's print the response over here. In case of function call, we can print the response using tool calls. Let's first go a step back and see what we get as a response over. So we have a function definition, and now we are adding one more argument called function definition, which we have already defined. Messages we have already defined over here. So let's run it. So we have a response over here. So we get this response to extract the main content. Here in this case where we are having function definition, we need to access tool calls. So let's run this. So we can better see it by extracting the first value and passing it function.arguments. So it gives us the clear picture. And now we have a consistent, reliable response. Every time we will run the request, we will get this consistent response, which is specified. Data scientist, location is this, company name was not there, so it is unnamed company. Job description is extracted, experience is extracted, and the skills are extracted in the form of a list which we specified, and each list item is a string. Another important point to note over here is let's have a look at messages again. Now instead of this message, let's say I comment this out and I change the message to something irrelevant. Tell me the capital of India. Now our message is changed, it's irrelevant, and function definition does not mention of anything of extraction, something like that. So what happens in this case? Do we get the response? In this case we get the regular content but no tool call, and if you will see that the value is none over here. If we will print this, we will get the response. We'll get error over here. We can simply print this and it will give us none in that case. What does that imply? It implies that LLM identifies when to use it. If the model detects that the user query matches this function's purpose, it outputs. Otherwise, it gives you a regular content like before. Another argument we can have a look at is tool choice equal to auto. This value is a default behavior of tool choice when we are not passing this parameter in this chat completion API, and it controls how and whether the model decides to call a tool. So this is the default option, auto. In case we replace it with the none, it means that model will never call any tool. It will respond in natural language only. And then there is a third option also where we can force the model to call the specific tool even if the prompt does not say anything about it. Now that you have learned how to use function calling to extract structured information from unstructured text, it's time to put that skill into practice. In the next lesson, we will work with medical transcription data and extract key fields relevant to healthcare application development, and you will see how function calling can be applied in the meaningful ways to handle complex domain-specific content. So get ready, we are moving a step closer to build powerful AI-driven healthcare tool. I'll see you in the next lesson.